vehicles, passenger vehicles, and powertrains. JAC has more than 20,000 employees and sells more than 600,000 cars a year. Since the first export to Bolivia in 1990s, JAC vehicles now can be found in 130 countries all over the world. JAC are enjoying high brand recognition among overseas customers. Okay, my team is established by Dong Yue, which is a cutting tool engineer. The rest of the team contains process engineer, workshop director, and mechanical engineer, and so on. Our team is a great team that formed with people who have passion to make their works better. Since the team has been established, we made a Gantt chart for the plan progress. As you can see, we have followed the plan progress. Since all the full information has been introduced, let's start with our project. Here is part 1, topic selection. And why is the roughness of RH05 hull is so important? Well, as the most widely used engine that's made by JAC Motor, the 4GB cylinder head is output is more than 200,000 per year, and it was used with the top 1 failure mode and took 49.5% of all the rejections. And why is it so necessary to improve the roughness? Well, the RH05 hull is used for install the water outlet pipe. If the roughness out of range, the water outlet pipe may follow, and the engines will out of cooling water, and that will boil the whole engine. And when the workers find the roughness out of tolerance, they have to exchange the tool which didn't reach the tool life, and that costs a lot of money. Okay, here's the current survey. As you can see, this is the RH05 hull, and the technical requirement for the roughness is RA 1.6. And according to the monthly quality report, the unqualified rate of tolerance reached 0.33%, which is exceed the qualified target of 0.21. After we select the topic and by measuring 40 cylinder heads, we have found the CPK is 0.73 and had a big risk of making unqualified cylinder head. And how did we prevent it installed in the engine? Well, there are two measures, but both of them are just have a continuous improvement of quality and cost a lot of money. Okay, here is the target setting. In order to make sure the qualified rate of cylinder head reach the workshop's qualified goal, the insured goal of the qualified target rate is 99.895%, and the challenge target is 100%. And can we make it? I think so. Because that team members are formed with talented people, and they are all well experienced. And compared with the other factories, the similar hull roughness is okay. So, I think we can make it. Here is the cost analysis part. Okay, first of all, I want to give you a brief introduction of how the RH05 hull is made. Well, in process OP20, 2 dowel pin holes has been made, and then the cylinder head transferred to OP30. And the clamping fixture clamps the cylinder head, and the RH05 hull will be rimmed by a rimmer. Through the flowchart, we can see the main process is in process OP20 and OP30. And the team has used cause and effect diagram to analyze all the potential causes that may have caused roughness out of tolerance, and use FEMA to analyze all the end factors that have been listed on the former paragraph. Through analysis, 5 potential keys have been listed out. Okay, since all the potential key factors have been listed out, we have made a plan to confirm the key factors. The plan started from April 1st to April 5th. The first potential key factor is the dowel pins wear down. Well, we let the mechanical engineer check the diameter of the dowel pins, but all the dowel pins are just match the technical requirement, so it is not the key factor. The second potential key factor is the pressure of the clamping fixture is inappropriate. Well, the mechanical engineer checked the pressure of the clamping fixture is from 26 to 34 bar, which is just match the technical requirement. And besides, we have promoted the pressure to 40 bars to see if it can stable the process, but nothing has happened. So this is not the key factor. The third potential key factor is the cutting tool structure is inappropriate. While inspect the cutting tool, which didn't reach the tool life, we found the leading part of the cutting tool was covered with aluminum scraps. During the tool life, it's not supposed to be any aluminum scraps adhere to the leading part. So, the quality of the R205 hole might be relevant to the leading part of the cutting tool. In order to know if there is any connections between them, 2 sample t-test was being made, and the levels are 60.4 millimeters and 15.8 millimeters, and the sample data is normal distributed. While the p-value is smaller than 0.05, rejected the null hypothesis, it is a key factor. Well, the fourth key factor, potential key factor, is the radial runout of the cutting tool is unqualified. While we improved the radial runout from 8 micrometer to 3 micrometer, but nothing has changed, so this is not the key factor. The fifth potential key factor is the cutting parameters of the cutting tool is inappropriate. In order to know if the relationship between feed ratio and roughness, we made a one-way ANOVA analysis, and there are 3 levels of factors. And by measurement, and the result shows that p-value is smaller than 0.05, so this is the key factor. Since all the factors have been identified, we come to the countermeasures planning. As we know, there are 2 key factors. The first is the structure of the cutting tool is inappropriate. All we do is redesign the cutting tool. The second is the parameter of the cutting tool is inappropriate. All we do is modify the parameter of the cutting tool. And here is the countermeasures implementing. Well, in order to get the best combination of the leading part and the feed ratio, and according to the team members' opinion, we designed the 2 levels and two factors experiment. And as you can see, the factorial feed result versus roughness versus feed ratio and height, the p-value of the main effect is smaller than 0.5. So the model is valid. And here is the residual plot. And the residual plot is normal. And because the feed ratio 500 millimeters per minute reduce the efficiency, meanwhile, rise the feed ratio to 100 millimeters per minute, the roughness is acceptable. Therefore, when the feed ratio set to 1000 millimeters per minute and the leading part height set to 15.8 millimeters per minute, the roughness of the R205 is the best solution. And we have redesigned the cutting tool the new height of the leading part is 15.8 millimeters, and the height difference is bigger than the cutting allowance. Okay, now here come to the effect inspection. After the measures being took, we have tracked for 1 month, and the quality of the RH05 hole roughness has greatly improved. And the qualify rate is 100%, which is a great improvement, and compares with the old roughness. The new CPK of the roughness is reached 2.72, and compared with the old 0.73, this is a great improvement. And here is the consolidated measures. Okay, we set 3 consolidated measures. The first one is redesign the leading part of the cutting tool, and the second is while the engineer modifies the cutting tool, they inspect the height of the leading part in the standing operating procedure. And the third is modify the cutting parameters of the cutting tool to 1000 millimeters per minute. Okay, here is the summary and future plan. The tangible benefit is more than 59,000 China yuan per year, and the intangible benefits include reduce the risk of making unqualified cylinder head and innovate a new check of the leading part of the cutting tools. And here is the summaries. And this QC circle has just reached the challenge target, and our ability has been greatly improved in this object. And the future plan is promote the surface quality of the OCV holes that use the experience that we get from this project, and analyzing and solving deep hole drill breakage from this activity. Thanks for your attention.